Hello and welcome back to a new lecture on syntax. In the previous lectures we spoke about constituency, we spoke about phrase structure rules, and we spoke about some common mistakes in drawing trees. But now we want to learn about how these different parts of a tree relate to each other. Are there any structural relations that exist between them? Therefore our topic for today is structural relations within a tree. So let's begin. Alright, so this is an example tree. From this tree you want to learn about what structural relations exist between these items. So first off, structural relations are defined as the formal relationships between items of a tree. So let's start to look at this tree, and first let's define some relations that exist between them. Now let's try to think of this tree as a family tree. Now in a family, you have a mother, you have a daughter, okay, like so. So we can apply that into this tree. The mother is the one that gives rise to daughters. Now they don't have to be two daughters, it could be one or three. These daughters to each other are sisters. Great. Now that we know what mother, daughter, and sister is, let's define some key terms here. In this tree, now there's a reason we call it a tree because it actually does look like a tree upside down. Now any tree has branches. All these lines here are called branches. Anything with a label like A, B, C, D, E, F, J, these are all called nodes. Now let's talk about these nodes. You can get something called a root node or a non-terminal node, also called a branching node, and you can get terminal nodes, also called non-branching nodes. So let's take a look here. The root node is the node that has no mother. The only one here that does not have a mother is this one. So this is the root node. You can also think of it as a tree or an upside down tree. There's only one part of the tree that's considered to be the root. Then you have a non-terminal node. It's also called a branching node because it's a node that has branches. So for example, C here has branches. It has 3 branches, as you can see. So this is considered a branching node or a non-terminal node. So is H, because H has 2 branches. B is also a non-terminal or a branching node because it also has branches. So is A, by the way. So A is a root node and a non-terminal node because it also has branches. Now let's take a look at the terminal nodes. Terminal node just means that it has no daughters. So which ones here do not have any daughters? Well, D does not have any daughters. Neither does E, nor does F, nor does G, nor does I, but also J and K. So all of these are terminal nodes, or non-branching, means that they don't have any branches coming out after them. But be careful now, H is not like K. H has some branches. So H is a non-terminal node because H has daughters. That does it for this C lecture. In our next lecture we're going to continue with our structural relations, and we're going to talk about dominance and precedence. See you there.